Good morning, ladies and gentlemen. We are on page 181 today, and our goal or our objective for the day is today I will decompose fractions into unit fractions to show multiplication. Okay, so let's talk about what that kind of means. Is we're going to decompose. Decompose, remember, means to break up and break apart fractions into unit fractions. So unit fractions are right here. A unit fraction is any fraction with a numerator of 1. So 1/5, 1/4, 1/9, 1/2. Those are all considered unit fractions when the numerator is 1. So that's what we're going to break our fractions into unit fractions. And the reason we're going to do that is we want to show multiplication. We want to show that how these can show or how they're equivalent or equal to multiplying. Okay, so our steps say we're going to represent the first fraction, and we can use a number line or an area model. And then we're going to label the unit fractions and write as a multiplication equation. Okay, so I'm going to get started on my first one. My first problem says, show that 2/3 can also be written as 2 times 3 using a number line. Okay, so my steps say that I'm going to represent my fraction. So I'm going to do this because they told me I have to do a number line. So I'm going to show what 2/3 on a number line looks like. Well, the 3 denominator means that I'm going to partition my 1 into 3 parts. And then that means that's 1/3, 2/3, and then 1 is equivalent to 3/3. So they want to know what 2/3 looks like. Okay, so I first did that. Now I'm going to show how this is. So when I jump from here to here, that is 1/3. And then when I go here, I add another 1/3. That's how I get to 2/3. So 1/3 plus 1/3 equals 2/3. But I could also say, instead of doing the 1/3 plus 1/3, I could just say 2 1/3 equals 2/3. So instead of adding them separately, I could say 2 of them equal 2/3. So I could show it as a multiplication problem, because that's what we want to show, is we want to be able to understand why it's a multiplication problem. Okay, let's look at another one. This one says, show that 8/5 can also be written as 8 times 1/5 using an area model. Okay, so I first need to represent this, and they want it in an area model. Okay, so 8/5, I'm going to use a circular area model. That means I need to partition this into fifths. And 8/5 means I have 1, 2, 3, 4, 5 of them. So I need to draw another hole because I have to have 8 of them. So if I had 5, I need 3 more. So 6, 7, 8. Okay, so this piece is 1/5. This is 1/5. That's 1/5. That's 1/5. That's 1/5. 1/5. 1/5. And 1/5. So if I was to add all those together, I have 1/5 plus 1/5 plus 1/5 plus 1/5. So there's the 5 here, 1, 2, 3, 4, 5, plus I have 3 over here, plus 1/5, plus 1/5, plus 1/5 equals, and when I add them up, I get 1, 2, 3, 4, 5, 6, 7, 8/5. So all those 1/5 together equals 8/5. But a shorter way to write this, instead of writing them out, I could say 8 times 1/5 equals 8/5. So 8 1/5 would equal the same. So this is showing it as a multiplication problem. Okay, let's try some together. So we are on page 182. And here is our first one. It says, show that 4/8 can also be written as 4 times 1/8 using a number line. Okay, so they want us to use a number line. So let's start, and I'm gonna draw a long one so I have room. And we have 0 and 1. Okay, because the denominator's 8 means I need to partition or divide this into eighths. So I'm gonna start by half, and then I'm gonna do fourths. So now it's 1, 2, 3, 4 parts, and then I'm gonna cut those in half again. So I should have 1, 2, 3, 4, 5, 6, 7, 8 parts. And let's label them. That's 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, and 8/8. Okay, and we have 4 of them. So let me lightly shade that. Okay, so to get to that, what I did is I jumped 1, so I went 1/8, then I jumped another 1/8, then I jumped another 1/8, and then I jumped another 1/8. So I really jumped 1/8 4 times. So it's 1/8 plus 1/8 plus 1/8 plus 1/8 equals 4/8. But instead of listing all these out, I could just say 4 times 1/8 equals 4/8. So it means the same thing. This is maybe just a shorter version of writing it. Okay, let's look at our next one. This one says, show that 7/6 can also be written as 7 times 1/6 using an area model. Okay, so why don't we use a rectangular area model this time? Okay, so the 6 denominator tells me we need to partition it into 6 pieces. So I have 1, 2, 3, 4, 5, 6. Okay, but the 7 means I need 7 pieces. So we need to draw another hole. And we need to partition that also into 6 pieces. So we have 7 pieces, and they're each 1/6 big. Each piece is 1/6 in size. So I have 1/6 plus 1/6 plus 1/6 plus 1/6 plus 1/6 plus 1/6 plus 1/6, 1, 2, 3, 4, 5, 6, 7 equals 7/6. Or I could just, instead of writing all 7 out, I could say 7 times 1/6 equals 7/6. Okay. When you do them on your own, ladies and gentlemen, make sure you pay attention if it asks you to do an area model or a number line, and you're going to be doing the next 3 pages on your own. Have a great day.